Welcome to video clip 6.5, in which we discuss the semantics of decision tables. The semantics of models in general describe their meaning, and the semantics of decision tables specifies how output is derived from the input. In DMN, the semantics of decision table is determined by the hit policy of the decision table. There are two groups of hit policies, the first being the single hit policies. In the single hit policies, the output of exactly one rule is returned. In multi-hit policies, the output values of several rules are used to determine the output. Several output values are returned, or we can also return an aggregate value, as we see in a minute. So let's start with the single hit policies. The simplest and most often used single hit policy is the unique policy. In the unique policy, for any given input combination, exactly one rule matches. We exemplify the unique single hit policy using an example of a health risk decision. We see the unique property here with the letter U on the upper left-hand corner of the decision table. Here we have input looking at the age of the person and also the medical history of the person. And if we take a close look here, we'll see that in any combination of age and medical history, we'll find one output. Therefore, we can say that the unique policy is fulfilled here. The unique policy should be used actually in most cases because it guarantees that for each input combination, exactly one rule matches and one output is generated. The next single hit policy we investigate is the any policy. In the any policy, for any given combination of input values, several rules can match. However, all rules that match must return the same output value, and therefore you can use any matching rule for determining the output. We'll have an example here of a credit policy compliance decision. And here we first of all have on the upper left corner the A, indicating the any single hit policy. Then we have inputs for the credit rating, for the credit card balance, and for a personal loan balance. And we can investigate the rules that are specified here in this decision table. And we find that some input combinations actually match several rules. For instance, the input combination credit rating is not A, credit card balance equals 10,000, and personal loan balance equals 60,000 matches the rules 2 and 4. So we have here rules 2 and rules 4 that match for this specific input combination. Next, we have to make sure that the output of these two are the same. And if we take a close look here, we see that for rule 2, the output is not compliant, and for rule 4, the output is also not compliant. Therefore, we can conclude that any is fulfilled here as well. The next single hit policy we want to investigate is the priority single hit policy. Here, for any given input combination, several rules can match, and these rules might even have different output values. Then the question is, so which output value is provided? And it is the output with the highest priority. And I'll come to this in a minute, using the example. Again, we have a health risk decision here that we want to look at. First of all, the priority single hit policy is shown here using the P in the upper left corner. And we'll have here certain rules. That means the first rule saying that if the age is at most 20 and the medical history is good, then the health risk is low, and so forth. So we want to take a look at the input combination 70 and bad. And we do that on the next slide. Actually, this input combination matches several rules, matches in particular rules 3 and 4. If we look at the output, we have high and medium. So rules 3 and 4 provide different outputs, but that's allowed in this context. The question is, what is the return value for the input 70 bad? In order to determine the return value, we have to take a close look at the ordering of output values in the output column. And here we have the ordering low, medium, high. So low has the highest priority and high has the lowest priority in this example. So the priority policy makes sure that only output medium is returned because medium appears in the output list before high. Right? And this is why the single hit policy priority returns here for the input 70 bad, just one output, namely the output medium. As this example shows, this single hit policy is not really very easy to understand because you need the output priorities to determine the output of the decision. Therefore, I think the priority policy should be avoided because of its complex and unclear semantics. The next single hit policy we take a look at is the first single hit policy. It can be considered a variant of the priority policy in which the rules are processed in order. And the first rule that matches determines the output. Of course, also in the first single hit policy, several rows can match a given input combination, but then only the first one is used and the output of the first one will be the output of the decision. We'll take a look at an example of a discount rate decision. Here we have the upper left-hand side, the F, indicating the first single hit policy. We have customer location as input, we have customer type as input, and we have the sales channel as input, and we have the discount rate then as output. If we look at the input combination VIC, standing for Victoria in this case, wholesale and web, we'll see that the first rule immediately matches. We can go into the detail here on the next slide as well. So rule 1 matches because the location is Victoria, the customer type is wholesale, and the channel is web. But if we take a close look here, also rule 3 matches. Yeah, because in rule 3, the customer location does not play a role, so any customer location is fine for rule 3. And otherwise, we have wholesale and we have web, and therefore we have 2 matches here. However, the first policy makes sure that just the first match will be returned. So in this case, the return value would be the 15% of the first rule. Okay, so the first policy should be used only in cases where an if-then-else logic of the rule semantics is appropriate. So if-then-else, many of you would know this from programming. If a certain condition holds, then certain statements are executed. If this is not the case, then I can continue. And that's exactly how this decision table is evaluated here. So if customer location equals Victoria and customer type equals wholesale and channel equals web, then discount rate equals 15%. Else, if customer location equals New South Wales and customer type equals wholesale and channel equals web, then return 10%. Else, and so forth. So you see this if-then-else logic is really how the first single hit policy is evaluated. We move on to the multi-hit policies. As indicated earlier, in multi-hit policies, several matching rules can be used for determining the output. We have a number of different policies with the multi-hit property. The first is the output order policy. The output order policy returns all hits in decreasing output priority order. So we use the output priority as we also did in the priority single hit policy. Output priorities are specified in the ordered list of output values in decreasing order of priority, which we have here. Okay, so here we use an example of a calculation of annual leave days. And we first of all have again the O here to indicate the output order, multi-hit policy. Then we have the age as input, we have years of service as input, and the age of the employee and the years of service are used as input to determine the number of leaves that person is eligible for. Okay, so let's take some concrete input. The age of the person should be 50, and the years of service should be 31. So we can now take a close look at this table, and we see that, well, the first row always matches because, well, the age doesn't play a role and the years of service doesn't play a role. So we can translate these to any person gets 20 days of annual leave. But also the rule 4 matches and the rule 5 also matches because the rule 4, age doesn't play a role, and 5 as well. And the years of service must exceed 10 for rule 4 and 20 for rule 5, which is the case, of course, when I'm for 31 years in service. So what does the order priority, the output order single hit policy now, let's say, returns? First, we have to look at the output. That is, for rule 1, it's 20. For rule 4, it's 5. For rule 5, it's 10. So we have 3 outputs, and we use this output to generate the final output, which is the ordering 20, 10, 5. Why 20, 10, 5? Well, we need to look at the ordering of the outputs in the head of the output column. And here it says the highest priority is 20, the second highest is 10, then the 5 comes, and then the 3 comes. So the output is not 25, 10, as we could imagine if we go from top to bottom, but the output is 20, 10, 5 in that order. The next multi-hit policy is the rule order policy. In the rule order policy, the outputs of all matching rules are returned as a sorted list in the order of the rules. So not in the order of the output priority, but just in the order of the rule. We use the same input, so again we have the same table. For the rule order, we have 1, 4, and 5 as matching, and we have the outputs 20, 5, and 10 as output. And now we just use the ordering of the rules, so the output should be 20, 5, and 10. And this is what we have here on the slide as output to this rule. The next, the final multi-hit policy is the collect policy. In the collect policy, the outputs of all matching rules are returned as an unsorted list. However, in collect, we can apply aggregation operators. And DMN provides 3 aggregation operators in the standard. One being the summation, then the minimum, the maximum, and the count, so the number of elements of the output list. We can look at the input of 50 and 31, so we look at rows 1, 4, 5. And we'll have here C+, so we have the collect multi-hit policy, and we have an aggregation, and the aggregation is the summation, indicated by the plus sign. So again, we have the outputs for rule 1, it's 20, for rule 4, it's 5, and for rule 5, it's 10. And now we have the aggregation operator, so we just sum up the values, and the values, the summation leads to the result 35, which is 20 plus 5 plus 10. So this is how we can use aggregation operators to evaluate rules. And this is an example of the summation, and we can also use the minimum. If we had used the minimum here, we would be returned the value 5 because it's the smallest, it's the minimum. If we would use the maximum, we would be returned the value 20, and the count would return the value 3 because we have 3 output values in the list. This brings us to the end of video clip 6.5, in which we discussed the semantics of decision tables. We first looked at single hit policies, namely the unique, any, priority, and first hit policies. And then we moved on to the multi-hit policies, looking at the output order policy, the rule order policy, and the collect policy, where the collect policy is associated with a number of aggregation operations.